All right. Good evening, everybody. All right. Good evening, everybody. Tonight we are going to cover one of the last two sections we're going to do this semester. So I'm going to make this week and next week the last two lectures for this semester. The um, assignment 7 I posted last night on Blackboard, and then assignment 8 I will have posted before next week, and that will be it for the semester. That'll compose your entire grade. It seems like most people are doing pretty well. I know I have some corrections to catch up on the last couple assignments, but I'm guessing most folks are going to continue to do well. So tonight I'm going to cover really a topic that's pretty important to everyone, and pretty important to DBAs, in that we're going to kind of dive into the creation of objects beyond just sort of tables and users, and start working our way into an actual little bit of programming. So assignment 7 is really centered around setting us up for assignment 8. And what we're going to do is we're actually going to create some a table space and a user and stuff we've already done before, and just get a little more practice with that. But then we're essentially going to create what will be the foundation of assignment 8, which will be a kind of mini data warehouse that we can go ahead and tune with our last assignment. And in the process of creating this table, we're going to be using the data we imported in the last assignment, and ultimately we're going to use procedures and work, create a couple sequences, and just get a sense for some of the kind of the real power of the database. So beyond just the day-to-day administration, start looking maybe just a little peek into one of the sort of typical use cases for a lot of databases, especially Oracle databases, is data warehousing and programming on the database platform. And then, next week we'll touch on a topic of SQL tuning, which is something that if you're administering a database, you will definitely be called upon to do. And it's really a primary responsibility of DBAs and those responsible for databases is to monitor and tune their performance as needed. So just getting started off here, I guess let me just show you the assignment that I've posted out on Blackboard here. So assignment 7 I posted last night, and really there's most of what you're going to see here is contained in this 4.7 SQL file, which I'll show you here in just a minute. But really, you're going to go through, create a bunch of objects, and then you're going to run this query and give me a screenshot of it. And this will just kind of prove to me that you were able to create all the objects that are kind of listed in this SQL file on your server, and that'll be how I determine your grade. You can see here I've got this set as I think the weekend before Thanksgiving week, and I will set the last assignment due date probably just the weekend before finals week to kind of give you guys time to get it done. But then also, if you want to get it done earlier and move on with the rest of your courses, that'll be your choice. But then I'll make sure I kind of force you to finish up before finals week so you can kind of get it over with and move on. So Assignment 7 will be kind of a little bit heavy duty. I think assignment 8, the last assignment, won't be quite as hard on you guys. And I also kind of decided that I think I've kind of put you through the ringer pretty well this semester. So, you know, I didn't want to take you right up to finals week with all the work we've done this semester. So I can see a lot of you have worked real hard at this. And I know you have other courses you need to probably submit final assignments for. So we'll get the rest of our course week work out of the way, hopefully maybe just a week or two before finals week. And then hopefully that'll give you guys the opportunity to catch up on everything else if I've been kind of banging on you too hard here. So, all right. This 4.7 sequel, if you take a look at it, it's got a number of tasks listed inside of it, and I give you a bunch of sequel. I think there's a total of 11 tasks in here. Some of the tasks are just centered on, hey, create this object, and then other tasks actually ask you to do things that you really ought to know how to do on your own here. So, for instance, the first task is to create a table space. We've done that before. You're going to create a user. We've done that before and recently. And then, you know, you're going to create some tables, and I've given you sort of a lot of the stuff you need to create these things. We're going to insert some values into a table, and then we're going to create tables using select statements, and then we're going to move into creating a number of procedures and sequences and populating some tables that will ultimately put together in kind of a typical data warehousing format. And then ultimately we'll combine all those tables together next week and do a little performance tuning and build some indexes on those tables next week. So tonight I'm really going to focus on showing you how to do all the tasks that are inside of assignment 7, and I'm going to talk a little bit about some of the tasks that we're doing and offer a little commentary on that as we go along as well. Yeah. Oh, was there a question?
No.
Okay. All right. So let's kind of dive right in. So for assignment 7, we're gonna be working on the same database we've been working on all along here, or my PDB1 on my CDB1, and we're kind of gonna start off as our sys user, and then we are gonna switch to a user we'll be creating in as our sys user, and then use that user to create a number of other objects. So here we go. First thing we're going to do is just go ahead and create a table space for our assignment. So I'm going to go ahead and create this table space. And you can see right here, nothing particularly special about this. I'm actually dropping the table space that I've created before and just show you how I can go through and recreate all these objects. So all the stuff I'm creating tonight, I'm going to call for assignment 7. You have slightly different names in your assignment file to make sure to be able to make sure that you pay attention to that. So the big thing here is we're going to make sure that this particular data file is a gigabyte, because we're actually going to end up creating a table that has several million rows in it as a part of the tuning exercise we're going to do next week. So, creating a table space, no big deal. We create it, we assign a data file to it, and we give it a maximum size. So I'll go ahead and create that. We can see I'm going to create a user here, so just go ahead and drop that user before I recreate them. The big thing about the user we'll be creating is we're going to set the default table space to the table space we just created for them, and then we're also going to grant our new user an unlimited quota on this table space, which basically means that this user has the capacity to completely fill this table space up if they want to. So run that, no big deal. We've created a user. We're going to grant the resource role to this user, the connect role so that they can create a session, and then ultimately we're going to grant this user select on the table that we would have created, I think, in the last assignment here when we imported data into the database. So, all right, I'll go ahead and execute the grants on these permissions, and you can see those all succeeded. And then we are actually going to create this table, but this is the point where we want to switch to our new user that we just created. So here is where we're going to switch to user we created. And so I'm just going to go up here. I've got this user all set up already, but you guys know how to create connections. Nothing too special going on there. And then I'm going to flip back to my sheet here, and over on the right-hand side, I'm going to switch from my sys user to this user I just created for the purposes of assignment 7. So make sure that this table doesn't already exist here. It's basically telling me down here that it doesn't. That's a good thing. And so then as this user, I'm going to create this state table, making explicitly assigning it to the table space I just created, although I don't necessarily need to do that because I've set that as default table space for this user already. Go ahead, create that table. Now that that table created successfully, I'm going to run this. This is a series of insert commands whose purpose is basically to just create us a table that has all the United States states and territories in it with their abbreviations in them as well. So you can see we're doing an insert into the code and name fields using the values here that we have inside the parens. So I'm just going to highlight all of these insert statements, and I'm going to click the create as script or run as a script here. And you can see it's just going to jam through and insert all 50 of those rows. You're always going to want to make sure that you commit your transaction after you've done that. So I'll go ahead and do that. Now we're just going to go ahead and actually create some other tables here. So I'm going to make sure it doesn't already exist in my user schema. And here you can see that I'm going to create this expanded table where we're going to take the Nebraska registration information we used on the last assignment. And we're actually going to do some things to it to kind of artificially inflate the table so that we can test the performance of our database. So we've got some interesting new sort of SQL techniques that we're actually using here. So if you take a look at this select statement, you can see the first thing that I've done is I have included more than one table in my select statement, and I've actually also included what's called a subquery in my select statement. And normally we would have joins on something like this because these various tables would have a relationship. But in this particular case, what I'm doing is I'm actually creating what's called a Cartesian product. So I'm intentionally not joining the tables together so that I can produce more data than I would otherwise. So what I'm saying is, hey, I have this table that we created last week that we know has Nebraska's data in it. And I'm actually going to take all of that data and use that as a simulation for all the other states and territories in the United States by including this state table that we just created in our query. And then I'm also going to use what's called a connect by query to essentially generate a row for every month of the year. So the net effect of this statement will be to create rows for every state and territory in the United States and for every month of the year 2015 by running this statement. And we can see if we run it right here that we end up with a result set that is 79,296 rows, and the actual result set that we're starting with is significantly smaller than that. And if we scroll down here, we can also see that, hey, we're creating these for various states and various month numbers too. So that is the sort of magic of Cartesian products, and is although when you hear about a Cartesian join, you might typically be referring to that as in the context of making a mistake, but we can actually use Cartesian joins to our advantage at times, and they can actually come in quite handy when we want to expand a data set one way or another. So, okay, the other piece that we've got going on here is, rather than defining our table, we're just, by explicitly stating the columns and the data types, we're just going to use a select statement to define our table. So I'm going to go ahead and create this expanded table as the result of this select statement. So I'm going to go ahead and run that now. And you can see that our table has been created. So the next thing that we're going to want to do is we actually want to generate a bunch of random values for a bunch of different years in over time. So, and this is all fake data, but oftentimes when you're trying to test something, you have to find a way to generate a bunch of sample data so you can test either performance or some other functionality. And so what we're going to do is we're actually going to use a case statement. And you can see right here that we're basically, on this line, we have a case statement. And this is kind of like an if-then-else statement. And what we're saying is if for any of the reg counts that we select out of this table, if the count is less than 10, then we want to add our reg count to a randomly generated number between 1 and 10. If our reg count is otherwise greater than 10, essentially, we're going to go ahead and add a randomly generated number in between 0 and 10 to our reg count. And the way that we do that is we're actually using two functions here. One is the round function, because the inner function that we're using, the random value, will generate a decimal value if we don't round it off here. So that's what we're doing. We're using the combination of these two functions to randomly generate a number between 1 and 10. And ultimately what this will do is just generate random results for all the various months, years, and states that we are trying to generate data for. So you can see if I run this particular SQL statement, it's unhappy about something I did here. You can see if we run this statement that we should end up with a bunch of randomly generated numbers here. So let me see, we'll take one more swing at this and see what we messed up. So, okay, basically what this is telling us right here is that we have some sort of oh, I see what the problem is. I've got basically a table name in here, I think, that is larger than it's supposed to be, because I didn't put the right table name in here. So it's essentially just telling me, hey, this table name you used is bogus because it's longer than 30 characters. If I go ahead and stick, let's see, this table in here now, we should see that when we run this statement, we will get some randomly generated numbers. And so what this statement is currently doing is we are, again, creating a Cartesian join with our state table. So we are essentially randomly generating different values for every original value in our table for all states and territories and for all months of the year as well. And so you can see here that we have cranked out these random numbers using this case statement up here. So, all right, we know that we can do that, and we ultimately want to use this functionality, but we have to have a method to cycle through multiple years. So ultimately what I want to do is I want to create 100 years of fake data, and I want to be randomly generating numbers for every row of data over 100 years for 50-some territories and 12 months a year to create what is really just a really huge data set. So right here you can see I'm just kind of demonstrating the the random value thing here using a random value between 1 and 100 in the round function. I can just use this to randomly generate numbers, and every time I run it, it'll come up with a different number. And so that's the sort of function that we're using inside of this. So what we're going to do now is actually create what's called a procedure. And on other ways you'll hear these referred to as stored procedures, but this is basically a piece of code that we're going to store on the database and persist, right? So once we create this procedure, here's the name of the procedure right here, after it's created, we can call this procedure from either other procedures or other blocks of code or SQL that we're using. We can call this and have it execute the code that's inside of it. So if we take a look at our procedure here, there's sort of two distinct sections, right? We have what's known as the sort of the declaration section right here, where we can define variables and their types. So I have a year variable here, and then I actually have what's called a cursor, which is a data structure that we can use to select values, and then we can iterate through those values and perform some type of operation on them. And then you can see where we have this begin clause, we actually have the section of code that we actually get to execute, right? So the first thing that we're doing here is we just have this little execute immediate, where we are truncating the table that we're creating. So every time we run this procedure, it will delete all of the data from this expand table that I've created. And the beauty of the truncate command is it actually allows us to bypass the undo and redo functionality that's built into the database. So when you just want to blow everything in a table away, truncate is quite a bit more efficient way of doing that, as opposed to using a delete statement, which would generate the undo and redo so that we could back up if we wanted to. So the downside to a truncate command is once it's done, it's done. So only use it if you mean it, because there's no coming back from this. There's no rolling back the results from a truncate command. So the next piece of our procedure here, you can see that we've actually got what's called a for loop, right? And this is a structure that allows us to loop either through a record set or through some sort of defined number set that we're using. And right here, we're basically saying, hey, we would like to loop 100 times. We're basically saying loop from 1 to 100, and this for I will just store whatever level of the loop that we're on here. So as we loop through this thing, each time we loop, the value of I would be incremented 1. So first time through 1, second time through 2, and so on and so on. And what we're going to do when we loop through here is every time we loop through, we're going to take our year variable, which we defined as an integer equal to 2015 up here, and we're going to subtract 1 from it. So we're going to go 2015, 2014, etc. until we get to 1915, right? Each time we get a different year, we're going to loop through our my cursor, which we defined up here. And our my cursor is that that statement that we were using above. So we're going to go grab everything out of our total reg clean table that we created in our last assignment that has 1 year's worth of data for Nebraska, and we're going to combine that with all of the states and territories in the United States, and we're going to do that also for every month of the year. And so ultimately what this select statement or this cursor will generate is a row for months 1 through 12 in all of the states. And you can see that we're referencing the state abbreviation here in this B code that refers to this table here that we've aliased as B. And then we're also in here referencing N for our month number, and we can see that's the value inside of this subquery that we have aliased as C. So each time we pass through here, we're going to insert the values that we're generating into the table we just created. We can see that we're saying, hey, insert into this table. We're going to put a value in for state, for year, for our reg types and subtypes and counts, and then lastly, our month number. And then you can see the values we're going to use are referring to this rec variable. The rec variable refers to each row that we select out of this cursor. So we're saying, hey, for each row in my cursor, perform this block of code right here, which is to insert another row into this expand, clean state expand table we have. And so you can see right here that we're going to use the values from our cursor in almost all cases. And you can see here we're using our case statement. We're using our random value statement to generate a random value to put into our reg count. And then lastly, we're using the month number that's generated from this cursor. The one value that we're not getting from our cursor is our year variable, which we're incrementing up here. So if we came into this loop the first time, this would be set to 2014, and that's the value that will get put into here. For 2014, we will loop through all of the states and territories in the United States, plus months 1 through 12. And then we will loop back around and we'll do the same thing for 2013. So you can imagine, you know, we have a basically, you know, somewhere around 600 or 700 rows, or 600 or 700 values that we're going to loop through for each pass. So this takes quite a while to actually perform this because we ultimately end up doing many, you know, many millions of inserts. And so when we run this thing, it actually takes quite a while. So, okay, to create this procedure, you can see we have this statement, create or replace procedure. It has a beginning and an end. If we execute this, we'll see down here if we've done it correctly that our procedure will be compiled. And now at this point, we have the ability to actually run this procedure. So I'm actually going to go ahead and run this, and this will take a few minutes to do. But I'll just show you kind of what you can expect here. So I'm going to kick this off, and you'll see that this probably takes a good 4 or 5 minutes to run by the time it's all said and done. Now, The next thing that we're going to create while we wait for this to finish is a date table. So when you're doing data warehousing, you will always need what is called a date dimension, or a table that contains a bunch of date values. And so we're going to create a table that has obviously a primary key, and it has a date value for each day. And then another thing that we usually do with these type of tables is we'll put in other attributes of a particular date that come in handy a lot of the time. So what number day of the week is it? What number day of the month is it? What number of day of the year? What's the previous day, the next day? What week of the year are we in? What month is it? The name of the month. What number month of the year is it? Quarter, and then obviously the year as well. And typically date dimensions will even be quite a bit larger than this, because there is a whole number of things that people will want to know about a particular day. And a lot of that just depends on the business case and what type of things are relevant about dates. But in a lot of cases, these tables might be 40 or 50 columns wide, with all the various information that people want to know about any particular day. A lot of times you'll get fiscal years and months involved for people's accounting periods. And then there might be dates there, or groups of dates that are relevant for marketing and other parts of the organization. These things get pretty big pretty quick. So in order to populate this table, we're actually going to go ahead and create another procedure. And what this procedure does is it just cycles through, and it actually just executes one insert statement. But our insert statement is actually going to use the sort of magic of the connect by statement one more time. And what this connect by statement really does is it gives us the capacity to kind of connect something to itself and loop through a number of times. So in this particular case, what we're going to do is we're going to start at 12/31 of 1900, and we are going to loop through every day between that date and 2049, December 31st of 2049. And the way that we're going to do that is we're actually using a state function on the database that says, hey, tell me how many days there are between the 31st of December 2049 and the 31st of December 1900, and then that's how many times we essentially want to loop through this statement and stick date values in it. And you can see what's happening is starting at this date, each time we pass through, we're going to add 1 to the date that we're using. And so we will first start off with January 1st, 1901, add 1 to it, populate all these columns, and then do that again for however many days there are between these two dates, which I think is 50 or 60,000 days. And then ultimately, after we create this procedure, we will run it to populate that table. And this is another kind of common way of doing data warehousing if you're not going to use maybe some of the large ETL tools like Informatica or ODI. A lot of folks will just build ETL, which is the code used to populate data warehousing tables. They'll just build it using procedures and groups of procedures that are all stored and contained and run right on the database. And it's one of the things that is very powerful about not just the Oracle database platform, but lots of database platforms. It's this ability to actually program right on the platform, right on the database. one of the biggest, sort of least used and most powerful capacities the database has is this ability to program. And sadly, a lot of people don't use it. They'll move this programming logic outside of the database and put it in the application layer, which is often, a very inefficient way of approaching doing these types of operations. So, okay, after we create that table, another big thing that is often used for a number of different things is what's called a sequence. So a sequence is nothing more than exactly what it sounds like. It's a structure that automatically creates a number and keeps track of what number it's on. And this is very handy for creating primary keys on tables. And in the data warehousing paradigm, it's very common to use integer-based keys to uniquely identify each row in a table. And the way that you actually achieve this is to have what's called a sequence. And if you take a look at how this object is defined, we're basically saying that, hey, each time you're called, increment yourself by 1, starting at the number 1 with a max value of, I think I got like 100 million in here, and the minimum value that you can produce is 1. Don't cache any of these values, which means don't barf out 10 or 15 at a time. Just fetch them one at a time. And then if you get to the end of your sequence, then just go ahead and start over at 1 and start generating numbers like that again. So we're going to end up creating a couple sequences that we're going to use in the population of some tables down the line here. So after we get done creating this very enormous table that we're in the process of creating, we're actually going to do what's called creating a dimension on this, right? So we have a measure or a value that we're interested in out of this table that we're populating right now, and that value is the registration count for some value of registration type or registration subtype. And then we're also interested in the reg count for particular states or months. And so rather than have those values, the values for those repeated over and over and over inside of our table, we're actually going to take them out and substitute a numerical value for them. And this is a common practice in data warehousing because it allows us to store the descriptive attributes for some measure that we're interested in a small table, and then just associate the key value to a much larger measure table. So to give you an idea of what I'm talking about here, you can see that our procedure has completed. And so if we go ahead and run a count on our table right now, we should see that we've actually created a very large table. And because and so there you go. Let's take a look here. We have a table that has 7.9 million rows inside of it. And those were all generated by this procedure that we just created. So one thing you get a sense of is, hey, even using a pretty relatively small amount of space, right? We only carved out a gigabyte for this data file, and we haven't filled it up. We're able to contain a table with nearly 8 million rows in it. But what this demonstrates is, hey, if we have a table that has 8 million rows, do we really want to store these state names and reg type and subtype, reg subtype names 8 million times when we really probably only need to store them, you know, maybe 50 or 60 times in a separate table, and we can substitute an integer value into our large table to represent those. So okay, come back down here. I'm going to go ahead and create this date table like we were talking about. So we'll just go ahead and make sure that it's not already created. You can see it's not created, so now I'll go ahead and run my create table statement, create this date table, and now I'm going to create the procedure that we're going to use to populate this table. So now I will highlight this block of code. You can see our procedure has been compiled without any errors. And now we're going to actually execute this procedure to populate this table with all of the rows from 1900 to 2049. And you can see, like, wow, that really screened through that pretty quick. If we take a look at this table, we can see that it does indeed have some data in it, and if we do a count on it, we can see that it's got 54,000 rows, so that must be how many days there are in between those two dates. To give you a sense of how quickly a database, even one as modest as the one we have, can process data. We inserted 54,000 rows that we're generating on the fly in less than a second. So that gives you a sense for just what you can do with databases. Now that we have this date table created, I'm just going to make sure that these sequences don't already exist. And so now I'm going to go ahead and create these two sequences. You can see that they've both been created. And so just to give you an idea, if you're ever sort of curious, like, geez, what does this thing do? I don't quite understand. If I say select and I reference my sequence and I ask it for the next value, and then I'm just going to say from dual, which is the sort of universal dummy table for Oracle when you want to do stuff with select and don't actually want to use a real table. You can see here, hey, there's the next value, 1. And in theory, if I run this thing again, I'll get 2. And then, this object keeps track of this internally. So if I were to come back, a day from now, it will still know that the last value that it barfed out was 2. So, all right, now I'm going to create a table for our reg types and for our reg subtypes. And to give you a sense of why we're doing this again, I'm just going to scroll up, take a look at our table that we created. So we know this table is nearly 8 million rows. Sorry, I can't execute it that way when I have PL/SQL on the page. We've got a table that's nearly 8 million rows. If you think about it, we know that there's only 30 or 40 probably of these reg type unique values, and maybe 50 or 60 unique values of the reg subtype. We also know that if we wanted to there's only going to be 54 unique values for, say, the full state name, but you know, it might be repeated hundreds of thousands of times in this table. So we're actually ultimately going to substitute numerical values in here that point us back to a much smaller table, so that if we want to do operations like summing these numbers up over either, say, for all passenger reg types or all handicap reg subtypes, we can actually use these smaller tables to perform those type of grouping operations. So, all right, let's come down here. We've created the sequences, and now we're just going to go ahead and create these two tables. And you can see what I'm doing here is I'm actually creating a value for reg type, and then I'm going to select the unique values of reg type out of this table and the unique values of the reg subtype. And then I'm just going to stick a 0 in there as a placeholder for the time being. And then we're going to create another procedure that will actually stick in those numerical values from the sequences that were created. So, okay, this is likely to take a minute or two to run as well, because we are looking for all of the unique values across a 8 million row table. So what the database has to do is it has to do what's called a full table scan. It goes through and looks at every row in that 8 million row table and decides whether or not it's a unique value or not. And you can see that ran in, what, about 10 seconds. So it took about 10 seconds to get through those 8 million operations. And now if we do a select on this table, we can see that across 8 million rows, we actually only have 10 unique values for this particular field. So that's you know, one of the reasons we're going to be doing what we're doing here. So there's you know, if we insert these values in 8 million times, and then it turns out we want to change this value to, say, trailer to trailers, rather than doing an operation that causes us to update a table 8 million times, we'll just update this 10 row table, and nothing has to change in the 8 million row table. So, all right, we're going to do the same thing with our subtype here. I'm going to go ahead and execute this. We can see that ran too in about 6 or 7 seconds. And then if we do a select star from this particular value, you can see that we end up with 89 unique values across the 8 million rows. And that's not surprising, because we started off with a file that probably had 89 rows in it for Nebraska, and then we just blew it out to be 100 years and 12 months for 100 years for 50-some states. Ultimately, there's only 89 unique values across that table. So we've created these two tables. We can see that this warehouse ID, or this what's supposed to be our unique identifier, is still set to 0, so that's not very unique at the moment. But the next thing we're going to do is actually deal with that. So, all right, we've created these two tables, and now we're going to create a procedure that actually populates them. So here you can see in this procedure I have here, the first thing I'm going to do is actually truncate the data back out of these tables, take it out of there. We're going to perform the same inserts that we basically performed as part of the create statement. And then we're going to update those WID values with the sequence values from our sequences. So I'm going to go ahead and create this. You can see our procedure compiled without error. And then I'm going to go ahead and actually run this procedure. And the way that we run a procedure is generally to use what's called an anonymous block. If we say our procedures, so what I am saying here is, hey, I would like you, dear database, to execute this procedure that I just created. So I'm going to go ahead and highlight that, hit the execute button. It's going to execute these commands. It'll probably take, I'm guessing, maybe 15 or 20 seconds to crank through that. And then after that completes, we should be able to go back up to these select statements here and see that we have the 89 unique values, and that each one of these values now has a unique numerical key that we will ultimately insert into that 8 million row table in place of the descriptive values. And this is one of the ways that data warehousing is much more efficient by using this approach. So, okay, we have created our procedures. We have inserted numerical keys into our tables. And then ultimately what we're going to do is we're going to create a warehouse table based off of the expanded table we just created. But instead of putting in all the descriptive values 8 million times, we're actually just going to insert the date key from our date dimension, the numerical key there. We're going to insert the WID value that was in our reg type table that we just created, and then we're going to insert the WID value or the warehouse ID value that's in our sub-type table. And then you can see in this case, at the last statement here, we actually are using joins, enforcing joins, and we're saying, hey, go to these smaller tables that have all the descriptive attributes about these measures, fetch the numerical key and insert it in here, and then ultimately when we get to assignment 8, we can join all these tables together and explore how you can make them perform quickly using what's called indexes. So I'm going to go ahead and execute this statement to create our great big warehouse table. And again, this one is likely to take a few minutes because we're using a pretty large base table, 8 million rows, and then we're joining it to several other tables. So we have to go through and basically 8 million times, we have to look up the value of the warehouse ID in our reg type table. We have to look up the value of our reg subtype table warehouse ID. We have to look up the code value from our state table, and then we have to look up the date key from our date table. So as you can imagine, 8 million times, what is that, 4 essentially is 24 million things the database has to do. So that takes a few minutes to do. And this is one of the things to think about. As you become a DBA, a lot of times what you do is you look at operations like this when you start to operate on very large tables. And in this day and age, 8 million rows is not really a very large table. But it's a pretty good threshold for where things can begin to get challenging when you start to get up into many millions of rows. But when you're looking at the way someone has written SQL, or you're trying to perform some operation on these large tables, you always got to kind of do that math where you're thinking about, well, how many times am I asking the database to do something? And is there a way that I can write a statement where, you know, it can be more efficient? If you think about this kind of simple statement right here, if I can get it to do one less thing, that will be in essence 8 million less things that it's doing every time I run this statement, or I run some operation that has to touch every row in the table. And so you can imagine when you begin working with tables in the tens of millions, and maybe performing operations across several tables in the tens of millions, that the efficiency with which you can perform operations, and the skill with which you can avoid doing things that don't need to be done can save you a great deal of time. Even with all the computing power we have these days in the data warehousing and really data processing area, one of the biggest challenges we still have is kind of the ability to get processing completed in what is increasingly less and less time available to do it. And incidentally, this is one of the big challenges in the big data world, and you know, Hadoop world as well. There you're dealing with data sets that might run into the petabytes, and trying to process data on that scale and process it in a timely manner is a very large challenge that people are still contending with. And the answer isn't always just throw more hardware at it, because there is a point where you reach a sort of diminishing returns applying that kind of logic to it. So there's a lot of folks who make their livings understanding how to tune databases and tune the processes that handle data processing to make them more efficient. So, okay, this will take probably another minute or two to finish up. But really what we've done here is we've gone through and touched on all of the things that you need to do for your next assignment. So the concepts that we've touched on is the idea of creating procedures, or really what is reusable blocks of code that can be called from other blocks of code, such as you know, schedulers or other SQL statements or other procedures. And we've also touched on some of the structures that other types of structures that are used in the database, such as sequences. And there are many, many other types of structures in the database that we could talk about this semester, but you know, there's you know, there's sort of a career down sort of every hallway of databases. So inside of just database programming, you know, there's a whole you know, career path on just learning how to program the database and all the things you can do with it. From the DBA's perspective, you know, understanding all these structures and how they're created and how to keep track of them is another thing. And then you know, performance tuning is yet another thing where you can focus your entire career on it. So we could see that that has completed now. And if we take a look at this table, we do a select off of this. We will see that we should end up with a table that still has many millions of rows in it. And it always helps when you spell things correctly. All right, so now instead of those sort of descriptive values for the registration type or subtype, we put in these numerical keys. Then we have a date key, which we can tie to a whole other slew of date attributes. And then obviously with our state, um, in our state table, we have the full name of the state, and we could store all sorts of other information about the state that we can then combine with these registration counts in here. And this is sort of a very simple example of kind of how data warehousing works. You have the smaller tables that store all these descriptive attributes, and then you have these giant tables that store the actual measures, such as car registrations in them, that can be associated with those. And ultimately, data analysis and data science is all built on the top of being able to do the various groupings and analytics across all these attributes that might matter somehow or another. So, perhaps we want to know all of the snowmobiles that are registered for the past 50 years, and that means something. We could use all the tables we've created to generate that analysis and do some sort of time, time variance on it or something like that. In any case, at the end of all this, when you are getting ready to submit your assignment 7, you're going to run this statement that shows that you've actually created all the objects that we've touched on here today. So you can see here when I run this statement, it says, hey, table or view does not exist, because at this point, I actually need to switch back to my sys user, because the new user I just created does not have access to this DBA objects table. So now I'm going to flip back to the sys user. You can see that this statement is showing us all the objects and the object types in the database that are owned by the user that we created. And of course, this syscontext thing here shows that I'm actually on my server. So at the end of the day, you should end up with something that shows us essentially 11 rows and proves that you created all the objects that are part of the assignment. And then come next week, we will actually dive into the subject of SQL tuning using this 8 million row table we've created in combination with the dimension tables that we're going to combine with it. And we're going to join all those things together, and we're going to do some aggregate operations, some sums and counts and max and mins across this data set. And we're going to figure out how we can tune that to make those operations really fast across really large data sets. So, all right, that's it for this week. That should give you a very big head start on really ought to help you get all the way through assignment 7. Make sure that you pay attention to the fact that the objects you are creating as a part of assignment 7 are not named the same as the objects I created tonight during the lecture. And obviously, if you have any questions, reach out and I will help you with this assignment. So that'll conclude this week's lecture. Next week, I will make sure I get the final assignment out, assignment 8 for you guys. Then I'll help you through how to complete that. And then you'll have, I think, about a week before Thanksgiving, and then another week or two before finals to wrap up, and that'll be your grade in the course. And then obviously over that time period, if there's any other topics that somebody wants to talk about, you're more than welcome to reach out to me, and I'll be happy to discuss them with you. If you have the textbook from this semester, then you'll definitely want to take a look at the textbook for your future reference. It's a great book that has even more topics that we haven't covered. And if you're interested in doing this type of work, then it is a fantastic reference for learning how to do it. I hope through the course here you've at least learn something. If you figured out that, hey, I don't want to ever do this kind of work, that's as good as figuring out if you do, in my mind. And I hope that you guys have gained quite a few new skills and have a better understanding how databases work as a result of it. So, okay, I'm going to go ahead and stop the recording here, and then I will take any questions that people have. And then if there's no questions, I'll talk to everybody next week.
Thank you, Professor.